This is question 7 from exam 1 Vcaa 2017. So let's have a look at this first question, which we've got to state the range of this particular function, root x plus 1. And it's really important, as always, to check the domain of these functions. So if the domain is 0 to infinity, 0 is our smallest x value. This is an increasing function. So what does 0 do? It starts at 1 and then just goes on to infinity. So it's pretty clear that the range of f here is 1 to infinity. That's not always obvious to everyone, and it might be an idea with questions like this to actually sketch the graph. And so we have a root x graph, but it's been shifted to the left, so it looks like this. Again, be very cognizant of the domain, and so it's not really starting at -1, it starts at 0, domain of 0, and so the range is going to be 1. So a graphical approach to ranges is often useful. Next part of the question. Here we've got to find a value for c in this domain so that the range of this function is a subset of that domain. So let's have a look at what we've got so far. We've got the domain of f and the range of f, and we want to find the range of g so that it's within this domain. And one way to do that, of course, is to sketch a graph. And this graph is relatively simple to draw if we factorize. And so we have an x-intercept of -1 and -3. There's our graph. And we can see our ranges from this turning point up, but we don't want that range. We want a range that is equal to 0 to infinity or smaller than. We can see a range of 0 to infinity would include this part and that part. So we want the range to be a subset of the domain. And we can see here that it's either this part or this part, but it makes sense for this part to be the domain because we want from negative infinity to c, not from -1 to infinity. So we get negative infinity to -3, and so the value of c is going to be -3. There's our answer mark. It's very likely that the method mark would be something to do with this graph or this factorization to find that -3. B part 2. Let's just write down what we've got so far. We've got the domains and ranges of f. Now for that particular value of c that we found, that -3, what would the range of f of g of x be? Before we do that, I think it'd be valuable just to look briefly at what a composite function f of g of x actually means. So we begin with what's sometimes called the inside function. So that happens first, and what's happening is that g takes values from the domain, maps it onto the range, and so x values become y values, and g determines how those x values become y values. And then once we've done g of x, we then need to take f, and it makes sense that the domain of f can't be any smaller than the range of g, otherwise there'd be elements of the range of g which don't get picked up, and that would be undefined. So this range of g has to be equal to or smaller than the domain of f for any composite function like f of g of x to be defined. So fog is only defined if the range of g is a subset of the domain of f. Okay, with that idea we can kind of move on to answering this question. What value for the value of c, which is -3, what's the range of f of g of x? And again, there's a couple of ways of thinking about it. First, we could find out what the composite function is, so we just substitute g of x into x, we work out this function, and we end up with x plus 2 squared square root. And then look at what we've got there, which is -3 is our domain from, what's the largest value there, what happens at -3. And at -3, you will add 2, get minus 1, square it, square root, you get back to 1. And if that number was any bigger, say minus 4, minus 5, this number is going to be bigger correspondingly. So we can kind of say, just like question 1a, that the range of f of g of x is going to be from 1 onwards. But again, it may be useful to sketch the graph. Therein lies a small difficulty, because we don't really sketch these kind of graphs in methods. It's called a modulus graph, and it's x plus 2, but there are no negative values. And the graph actually looks like this. So you have a graph of x plus 2, which would normally pass through here, but whenever we get values less than minus 2, because it's squared, it becomes positive, and then we square root, and so we get this bottom line here always becomes positive, which we call a modulus or absolute value graph. Further complicated is the fact that the domain of G is only negative infinity to minus 3, and so the graph is somewhat restricted, and so the range is from 1, where if we get x equals minus 3, the y value would be 1, and so the range of this particular graph is from 1 to infinity. So there's two ways to explore this. One is to look at what this function is doing at the domain of minus infinity to minus 3, or to sketch its graph. And I appreciate that sketching this graph is problematic, as it is in the next question. So the next question asks for us to find the range of f of h of x. So let's go ahead and find that function. So if we've got h of x plus 1, we simply have x squared plus 3, which is our function, plus 1, and we get x squared plus 4. So let's have a look at those domains and ranges that we have so far. We have a domain of h being the real numbers. We have the range of h. If we think about this carefully without even sketching a graph, it's the parabola plus 3, so the range is going to be 3 to infinity. We have the domain of f from before, and we also have the range of f. So we want to do the composite function, though, of f of h of x, and so there's a couple of ways of doing it, is to look at what's going on here. If we have a domain of f being from 0 to infinity, if we put 0 in there, we get the square root of 4. So the number is 2. But we can also look at this from a graphical point of view. And this graph, x squared plus 4 square root, again, not easy to graph, but let's think about shape on the basis of, say, intercepts. So again, if x is 0, we get square root of 4, which is 2. If x is increasing, this function will increase, and if x is negative, the square of that negative just means we get a reflection of the same shape on the right as we do on the left. So this is the graph of x squared plus 4, and with that graph we can see from the domain of 0 to infinity that our range is going to be from 2 to infinity. We didn't really need to sketch that graph to do this, because if we look at the domain of f being 0 to infinity, the smallest value of this is going to be 2, and then it's going to increase. But sometimes a graphical approach helps us to visualize what's going on. So in summary, with all of these questions, it is possible to find the ranges of these functions and find the rules without really sketching a graph, but sometimes sketching a graph, as difficult as it can be, helps you to visualize what is going on with the domains and with the ranges.